cold out here. So let's go through some trigonometry practice. Now that we've learned what we're actually going to be using, let's actually put it into application. The first two problems on your worksheet are number 1, number 2. We've got a triangle here that has a specific degree. It has the measurement of one side, and we're missing the side B and the side C. So we're going to figure out what B and C are. The way we're going to figure out B is we're going to use our trigonometric functions. The way we're going to figure out B is using our trigonometric functions. Say that 3 times fast. The way we're going to figure out C is using the Pythagorean theorem. So, to figure out B, I've got this 15 degrees, so I need sine opposite over hypotenuse. So, opposite over hypotenuse. Well, I don't know opposite and I don't know hypotenuse. That's not going to work. Cosine over adjacent and hypotenuse. Adjacent, I know adjacent, but a hypotenuse I don't know. I could use that to find the hypotenuse, but what I really want to do is I want to use the Pythagorean theorem to find that one. So TOA, T, tangent, is opposite over adjacent. That's my opposite, that's my adjacent, so I can use that one. I'm trying to find B. So I'm going to do TOA. That's going to be tan theta equals opposite over adjacent, which in this case is going to be tangent of 15 is equal to the ratio between B over 10. So the way I figure out B is I just take tangent 15, multiply it by 10 is equal to B. So let's go ahead and calculate that. Very easy. Your calculator should all have a sine, cosine, and tangent function. So I take the tangent function, put it into 15, and that's going to be times 10. And that should give me a 2.6. So 2.6 meters, actually that's going to round up to 2.7, equals B. So B is 2.7 meters. So then I find C using the Pythagorean theorem. That's going to be A squared, which is 10, plus B squared, which is B, equals C squared. So A is 10, so 10 squared plus B, which is 2.7 squared, is equal to C squared. So the way I'm going to get rid of this square is I'm going to square root this whole thing. So I'll take care of that. So then 10 squared is 100. Plus 2.7 squared is 7.29 square root equals C. And then 100 plus 7.29 is 107.29. Square root of that is going to be 10.35. So my C is 10.35 meters. Nice and simple, right? Okay, let's do the other one. So the other one, I have my A value, I have my B value, I'm looking for my C value and my tangent value. Okay? So let's first find our C value, since that's really easy using the Pythagorean theorem. So that's going to be A squared plus B squared equals C squared. So therefore, we'll say 10 is A. 10 squared plus 15 squared equals C squared. We'll square root both sides. So 10 squared is 100 plus 15 squared is 225. Square root of that equals C. Then 100 plus 225 is 325. And square root of that is 18.03 equals C. So C is 18.03 meters. And then theta. Well, how do I find theta? Well, I've got any one of these options. So let's just go ahead and use the first one, sine. So is sine of theta equals opposite over hypotenuse. Using so, that's going to be sine theta opposite over hypotenuse, which the opposite side to this angle is 15, divided by the C, which we found was 18.03. So that'll equal some specific value. And that'll be 0.832. So when I'm using sines and cosines and tangents, I usually like to keep my decimal places to the third place. I find that gets me a more accurate angle on the other side. The thing to keep in mind here is when we're using sine and cosine, remember it's opposite over hypotenuse and adjacent over hypotenuse. And the hypotenuse is the longest side of that triangle. So you should always have the smaller number over the bigger number. Cosine and sine will only work with something under 1. It will never be 1 point something. If you have 1 or greater, then your sine and your cosine will not work. You have set it up incorrectly. So 0.832, that is a valid number to use. So the way we're going to do that is on our calculators, we have this handy little function next to our sine, cosine, and tangent of sine to the negative 1, cosine to the negative 1, and tangent to the negative 1. Now what those are is those are doing the opposite. That's how you remove it from the other side. What that's basically saying is something to the negative 1 is the same as saying, so if I have sine to the negative 1, that's the same as saying 1 over sine. So if I have sine theta equals 0.832, I need to divide both sides by that sine function. And so the way I'm going to do that is by using that sine negative 1. So it's going to be the same as saying theta equals sine to the negative 1 of 0.832. Okay? If you're confused about that, let me know. We'll figure this out together. I'll explain it in different ways. We'll get it all fit together. But so that you know, what's happening is sine to the negative 1 multiplied by that little decimal point is going to result in the angle of this triangle. In the same way that multiplying sine times the angle is going to give us this ratio. So that's how we can convert between the two. So, punch sine negative 1.832 into my calculator. That will give me 56.3. So theta should be equal to 56.3. Put that in right here. Okay, let's go ahead and take a look at the next two. Okay, so the last three on this worksheet, just for our practice, we're being asked to find A and C of a triangle that has a degree of 32 degrees and 15 meters on the side opposite to that angle. So, A is going to be given using sine, using tangent opposite over adjacent. So tan of theta equals opposite over adjacent, equal to opposite being 15 over A. Okay. So this one's going to be a little bit different. Just because tan theta is equal to 15 over A, I can't just multiply tan theta by A. So I'm going to have to switch these two out. So I multiply both sides by A to get the 15 alone. It's going to give me A tan theta equals 15, and then divide both sides by tan theta. So it's going to give me A equals 15 divided by tangent of theta. Theta being that 32 degrees. So we can go ahead and calculate that. You can put that into your calculator. So you would put in 15 divided by, most of you are going to use the second function, tangent of theta, which is 32. and that will give you a value of 24. So A is equal to 24. Then again, using the Pythagorean theorem, a squared plus b squared equals c squared. So it's going to be a squared plus b squared equals c squared. Then A is going to be that 24. 24 squared plus 15 squared equals c squared. Let's punch those values in. So it's going to give me 801 equals c squared. Square root both sides, and that will give me a value of 28.3 for c. So c is equal to 28.3. Okay, so now we've basically seen all the different types of situations that we'll encounter with triangles. Let's get into the applications that we are actually going to be using. In number 4, we have a vector force. So we have a force that is being applied in both the x, in this direction, and the y, in this direction. How do we figure that out? Well, we have the angle and we have the hypotenuse. Okay? So this resulting vector is going to be the hypotenuse. The hypotenuse is always going to be the angle, the vector that's moving in neither the y or the x. It's the thing that's moving at an angle apart from the two. Okay? So 254 is going to be our hypotenuse. It's going to be our c, the c of our triangle. So we can use sine opposite over hypotenuse to find the component on the x side. Or I'm sorry, opposite. Opposite is going to be the y. So it's going to be the y side. So I can basically draw out my two components as if it was just a triangle. So this force vector is made up of an x component and a y component. This y component is going to be given by sine opposite over hypotenuse. So sine of theta equals opposite over hypotenuse. Another way to say that is the hypotenuse times the sine of theta is equal to the opposite side. So, in this case, that hypotenuse is at 254. So 254 times the sine of 27 will give me my y. So let's go ahead and punch that into our calculators. And that'll give me 115.3. That'll be 115 newtons in the y direction, upwards. That's applied straight up, okay? The x is given by cosine, because it is the adjacent side to the angle. So, cosine theta equals adjacent over hypotenuse. Again, another way of saying that is hypotenuse times cosine theta equals the adjacent side. And in this case, that hypotenuse is again at 254. So 254 times the cosine of theta, which is 27, equals x. Okay? So 254 times the cosine 27 is going to give me 226 newtons. Okay. So a way we can check that is using the Pythagorean theorem, because a squared plus b squared equals c squared. So this value squared should be equal to 226 squared plus 115.3 squared. So let's go ahead and try that out. 115.3 squared plus 226 squared. But if I square root that value, I end up with 253.7. Rounding up, that gives me 254. So those values are indeed correct. What does that mean? Well, when we're working with forces, if I pull something at an angle, I'm literally pulling in the y direction and the x direction. So if I have a box that I'm pulling along a table, it has a certain force of friction. But if I pull it at an angle, part of that force is pulling it up off of the table, and it causes that friction to go down, just like we saw in the last problem on our friction worksheet. Okay? So it's very important that we get these values correct. Now, let's take a look at our last type of trigonometric problem. We have our y component and our x component, and we are tasked with finding the hypotenuse, the resulting vector. So the resulting vector is going to be something in this direction. I mean, I can think about it this way. If I push on two sides of a box, if I push on this side of a box, someone else pushes on this side of a box, it's going to go in that direction at a certain force, dependent on the forces that we each apply. Okay? So let's go ahead and figure this out. 475 and 654. Well, those two together make up the A and the B of a right triangle. Because another way we could draw this vector is by saying, okay, let's take this y and put it over here. So it's going to be that. And then we've got a triangle right there. Okay? So our triangle isn't going to be going this way. That wouldn't make sense. So we actually have to move our y over to get that triangle. Okay? I want you to be careful with that because you can end up drawing your vectors in the wrong direction. Remember, if you have two vectors on the x and the y, your vector that is the result is going to be somewhere between them. It's not going to be this way, it's not going to be this way, it won't be opposite, it'll be somewhere between these two values. It should make sense. So, 475 squared plus 654 squared and square root that whole thing will equal c, and c will be my resulting vector. Okay, let's go ahead and do that. And that resulting vector is going to be 808.3 newtons. Okay. Now, the way we find this angle, this theta right here, and we're using the angle off of the x-plane, and we're almost always going to be doing it that way. We're going to use tangent, opposite over adjacent, because we have the opposite, which is this 475, over the adjacent. So, tangent theta equal to, and we're going to say the opposite is y, so we're going to say y over x. Okay, it's that same ratio. Again, same thing. So the way we find this is we say theta equals tangent to the negative 1. Remember, tangent negative 1 is just 1 over tan, which will cancel this out and allow me to find the theta. So it's that times y over x. So let's plug our values in for that and solve it. So theta is equal to tan negative 1 times y, which is 475, over x, 654. Now, the values for sine and cosine always need to end up being less than 1, but tangent, it's a very different function. It doesn't care as much. If we graphed this out, you would see that difference very clearly. I'm not going to graph it out in this video, but if you want to know, let me know. I can show it to you. So, 475 over 654 times tangent negative 1. That's going to give me a result of 35.9 degrees. So this theta equals 35.9 degrees. Now, we can check that using either so or ca, using sine or cosine. It's going to make the same difference. Okay? Let's go ahead and look at that. So checking our answer with that, I'm going to go ahead and use sine theta times my resulting hypotenuse, and that should give me this y right here, this 475. So sine of 35.9 times that 808 should equal 475. And it actually brings me a value of 473.9. So we are 1.1 away. Out of several hundred, that's less than a 0.25% difference. So we're very nice and close. That's perfect tolerance. Okay, let's get on to actually applying these to our forces problems.